Hello. Hopefully we've got sound this time, and not just sound. Yes, we've got sound. Hopefully decent sound, and we're starting all over again. So thank you for joining us. And this is for 7 to 18-year-olds. We're going to cover different things. We're playing rock, paper, scissors. If you've been with us over the weekend, then you played a few times. If you haven't done it, I'm going to show you how to play it and what to do, and then we're going to look at the maths behind it. And hopefully my friend Shane is watching, and I'm hoping that my friend Shane will actually come up with some input, ideas, extra things we can add to that, because he is a bit of a writer, a bit of a mathematical writer, and got lots of wonderful ideas on how to make maths real life mathematics. That's Shane's speciality. Hopefully he's going to come and do another live with us one day soon. So my name is Caroline from Bubbly Maths. My name is Caroline from Bubbly Maths, and I'm presenting these for AIMSEC. And all these activities that I present are on the Aiming High website. And the link to the Aiming High website is in the description. Now, just going to quickly make this into a watch party as well, so that more people know that we're here, and hopefully you can hear us. And I'm also going to activate this so that I can hopefully see messages. One of these days, I actually will see the messages as they come in. I haven't not seen it yet. I'll put the link in the watch party as well. So if you want the watch party, you've got the link in the description and in the group. No, one more time, because 2 more seconds, refresh, and then hopefully I'll be able to see the comments as they come in. So, yes, right, I'm playing it, and hopefully that means I'll be able to see the comments. We'll see. Everything slows down when you're on Zoom. So what we're doing is we're playing rock, paper, scissors, and I'm going to show you, if you didn't see any of the lives, I'm going to show you how we're doing it. We're recording what we're doing. So Grandma and Leo were playing together. So we have one column. I'm going to just reduce that to one column. One row, I should say. One set of data. So we had Leo, Grandma, and Winner. And what we did, we played 10 times to see what would happen in 10 goes. So we had 10 trials. And in this particular case, we had scissors, so it had a tie. Then Leo did rock, Grandma did paper, so Grandma won. Then, how do you play rock, paper, scissors? So rock, paper, scissors, you stop, you close. A lot of people know. If you don't know, rock, 1, 2, 3, and you choose rock, or you choose paper, or you choose scissors. And rock beats scissors because it blunts scissors. Scissors beats paper because it cuts paper. And paper beats rock because it wraps rock. And one of the things for you to think about is, what is the likelihood of any of those outcomes? And how likely is it for somebody to actually win? And is there a way you can actually strategize? Is there a strategy you can create when playing fairly that means you can be sure of winning or increase your chances of winning? Those are the questions we're thinking about. But first thing we're going to do is play the game. I'm going to put this down. Remember to pick it up again afterwards. Okay, here we go. What's different about, we're playing rock, paper, scissors. So we're doing the bit with the rock, paper, scissors. I've got to see make sure you can see what I can see. I can see what you can see. Lower it a bit more. Okay, right, so what you do is you start the game off, both of you, facing each other with your feet together. And then you do 1, 2, 3. So if we both got scissors, it's a tie. If Leo had paper, I win. And if Leo had a rock, then he wins. So you write it down. Let's say we both had, I did scissors then, didn't I? So there you go. Grandma did scissors, Leo did scissors,
the other night, and it was a tie. You write it down, but you write it down here, obviously, and move across. But what happens is whoever loses, neither of you lose, you don't move, but if one of you loses, then you have to just open your feet out a little bit. And then you, every time you lose, open it out some more, some more, some more, some more, some more, until you do the sideways split. The first person to either fall down or put their hands on the floor to hold themselves up is the loser of the championship, let's say. And then you can keep playing, and you can, and now the other one, got it over here. So you start off, that's Leo's feet, 1 foot, 2. He's at summer camp right now, so he can't do it. But you start off like this. So those are his feet, you've got to pretend, and these are my feet. If you win, you take a step back. So let's say I won twice, but then let's say Leo won, he's been, let's say Leo won, then I've got to take my front foot and go forwards and touch his toes, which is fine until it's super, super long way away, in which case you do the frontward splits, and the first person, again, touch the ground with their hands, or if they fall over, touch the ground with anything else, is the loser of the championship. But in the meantime, you're accumulating data, and that's the maths of it. That's what we're doing for playing the game, and we're accumulating data, and using this data, we can then do the maths. You can find out if there's a way, that's your job to think about that, there's a way of winning. Now here are the questions. Let me just double check everyone can hear okay. Ooh, Shane reckons he's read a paper on a strategy to win this game. Well, can you find out for us, Shane? We're all ears. And let's see if there's anybody. Oh, see, the watch party hasn't even started yet. How slow is the watch party? Right, okay, so what we're now going to do is I'm going to look at the activities for you to do. Now, in 40 minutes, I'm going to do a live for early years, so that will be from age 4 to 7. A 7 can do both, basically. And whichever, I mean, it's all fun. It's all to do with rock, paper, scissors. We're going to start off now with what to do with, so if you're 7, just now, 7 to 11, the idea is we want to do this. So we're going to do it. We're going to record, somebody's going to record what we're doing. Then we're going to talk about it. We're going to talk about, play the game, record what we're doing, and then we're going to talk. So here are the questions. What are the different things that can happen when you play this game? So how many different options are there? Find a way of recording them all and make sure you have all the possibilities. So you both have scissors, Grandma has scissors, Leo has paper or rock, and then also whether that's winning, tying, or losing. No, yeah, whether Grandma's winning, whether Leo's losing, whether you're tying, and all the different ways you can do it. So how many possibilities are there? And that's super important to work that out. Now, so it's called how many different events, using the proper language, happen when you play the game. You want to see if all the events, like we played it 30 times here, have all the events, all the possible outcomes, have they all happened during this time? And if you maybe have a whole group of people, again, you can do this on Zoom. If you have people, you can play this, especially the sideways split, the first one when you start with the feet together. You don't have to be in the same room, but you do need to just have one opponent, one person you're playing with. But you can have a Zoom with lots of people on it, and you decide, right, Joe's going to play with Julia, and you just choose one person that you're playing with, and then you can record it. Ideally, somebody else would record it, but if you've got to remember to record it if you do it yourself, like write out the chart like this. And so work out how many events there are. So first play the game, and then think about how many different possibilities there are, and then did they all happen? Check that they all happened, or did they might not have all happened. And then how many ended in a draw, how many ended up with you winning, and how many ended up with your opponent winning. And I'm not quite sure what that question means, so I need to ask that question afterwards. And then here's the question. Are you equally likely to do scissors? Oh, sign. Okay, so when talks about sign, so I'm reading what Tony's written on the Amy Highway. So the sign means, have you done, this is the sign for rock, this is the sign for scissors, this is the sign for paper. So what makes you decide which sign to choose? And are you equally likely to do scissors, paper, scissors, rock, or paper? And explain if you are you're likely to do equally likely to choose any of those three, say why, and if you're not, say why not. And are you sure you've got all the possibilities? How do you know you've got all the possibilities? And is it a fair game? Now, we are talking about fair if everyone's playing fair and nobody checks. Sometimes it's better to keep your eyes closed until you've chosen your sign, because sometimes it's really hard, especially if you're playing with a 4 or 5-year-old. It's really hard for them to not wait for that moment to see what you've done to do. Now, with these games, I know he didn't do that, but there were some games when I know Leo was waiting for me to do it so that he could, because he just felt he had to win. And so you need to be aware of that. So you could do it where you have to close your eyes. And is it a fair game? Do both players have the same chance of winning, assuming that no one's waiting to see what somebody else comes up with? So it's super important that everyone comes with the sign at the same time. And then you're recording it. And this is just all, and then we're looking for all the different possible events. So find a way of writing down all the different possible events. You could do it in little boxes, and then how can you be sure that you've thought of them all? And now, if you're in upper primary or lower secondary, you might call that the sample space. Now, how to record what you want to do is record them like this. You could have recorded them in a different way, but if you record them like this, for me, I need to do something super tidy like this, or else I don't even know what I've written. I can't read it afterwards. And so there are other, if you look, download the activities. And for the lower secondary, as in if you're 11 to 15, there's lots of extra bits in the activity for you to follow. Say, well, if I'm not sure how to do this, just go ahead and have a look on the activity. You don't have to print it out. You can see it's a PDF, and you can see it quite clearly if you download the PDF. The link is in the description above. And I'm just going to say it. You'll work out how many events can happen. There's not that many possibilities. And so the question is, what is the chance? Now this, maybe we're looking at 11 to 14-year-olds now. What is the chance of Leo winning? What is the chance of grandma winning? And we use the word probability. Now, if you can decide what the chances are, if you're 7 to 11, we call that probability. What is the probability that grandma would win, or you would win, or your opponent would win, your player 1, player 2 would win? And what is the probability of a draw? What is the probability of a tie, that you both come up with the same symbol? So I'm not going to give you the solution. Why are we doing this? We're doing it to enjoy the activity, and then make it relevant to real life. So why is it important to do this sort of thing? Well, there are situations when in life where we're always, this helps us solve problems. It helps us make decisions. So for example, if you've ever heard when elections are happening, they talk about the polls, and before the elections happen, they say, well, we did a poll, and with this poll, this many people are going to vote for this person, and this many people are going to, or this percentage of the population are going to vote for that person, but we're not absolutely sure, and those people could change their minds, or maybe they haven't decided yet, and so we're looking at probabilities. We're doing a best guess based on some data, but it's not certain. Now, and so we want to know how likely it is. Another one, if you, like when it's Christmas time or when it's a season for buying toys, maybe Eid coming up or Hanukkah, the shops will think, okay, what's going to be the most popular toy this year? But the thing is, they have to place their orders way earlier in the year. They can't wait till the orders start coming in to order them, because the factories have to make the toys. And they can't wait till the day before, because that has to be done months in advance. And they have a fair there's a toy fair, big famous toy fair in Germany, and they all have to go there. They all place their order. They have to go there, but they can go there and place their orders, and they have to think, what is the most likely thing to sell this year? If they get it wrong, then you might not get the toy you choose, because there might not be enough toys for all the children, and they might end up with a warehouse full of toys that no one wants, that no one's bought, that they can't even sell till next year, if they're lucky, because there are times when there's lots of toys. Like, for example, if you want to go swimming in the summer, swimming costumes, toys to go in the water, and what other things, just holidays, going on holidays in your backyard. So this year, fans, if it gets hot, are you going to need a lot of fans to keep cool? All those things that the people have to guess, and it's called probabilities. And you have to think, well, what is the best guess? And it's going to help you make these decisions. Now, how can that affect you? Well, you might want to go out and play. You might want to decide to have go out with a ball and play outside. But if that's your plan for tomorrow, you might want to check with the weather forecast. And the weather people, they have a lot of scientific data, but it's not absolutely certain until it happens. If it's raining right now, then 100%. We have a probability of 1 that it's raining. But before that, we don't know for certain that it will rain. And so a lot of life, the plans that we make based on what we think is going to happen. And the weather forecast is based on what the weather people think is going to happen. And the toys that are in the shops are based on what the toy sellers think is going to sell. And then when it actually happens, when we test it, called experimental data. It's not theory, it's not absolute, it's experimental. We actually do it and see. And the other things, that how does it work? Like, how many schools to build? How big should the school be? So predicting how many children are going to want to live in that certain area, what playgrounds, and how many playgrounds, where to build them, and should there be a swimming pool in this area, or should they build another swimming pool, or maybe close this one down and open one somewhere else? All of these things have to be planned, and they're all based on probability, and that is why this is so important. So the things that you're learning how to do is you're having an experience with a game that requires mathematical thinking about probability, because what you're doing, even though you're only playing a game, your mind is thinking, what shall I do next? What's the best thing to do? Will I win if I do this? Will I win if I do that? And your mind is doing all of that, even if you're not thinking it through. And then you've got to develop, when you then process the information, you're using mathematical thinking, you're developing your mathematical thinking skills to work out how many different events there are, how many different possible combinations of the different signs, and then you're understanding about all the different samples, all the different possibilities, all the different combinations, and looking at whether or not it's a fair game, if there are equal chances in a fair game, or is there a sort of way that you can actually have a strategy to win, or is it all going to be equal? Is it? Then you're thinking about all of that, and that's what you're learning. And then, so you're going to thinking mathematically, you're reasoning logically, you're communicating. So you do want to be talking about this. You want to use think, do, talk, think. Let me get this right. This is my I don't know, I can't call my friend, but somebody I really admire. Do, talk, record. So we're recording, but we're doing, first we're doing and then we're talking. So we're doing something and then we're talking about it. We want to talk to each other. We don't want to explain. We don't want people to explain to us, do we? We talk between children, or as the learner, you're the expert in learning in your own head. So you want to talk with a grown-up or an older sibling or another person the same age as you and talk about it and think, well, what would happen? And decide for yourself. Think about it yourself and talk about it. The more you talk about it, the more you explain to someone else what your thoughts are, the more your thoughts will get clear. And that's super important. And so we're communicating, and you want to look at the probability of winning. How likely is it that you're going to be able to win? Can you improve your likelihood of winning? So you're developing life skills. And whenever you're playing games, you're learning to be considerate of others, and you're learning how to handle failure. And the thing is that there's no such thing as a mistake. There's no such thing as failure, because it's all experience. It's all learning, and it's all developing your emotional intelligence. And all of this is all part of the process. So there's more in the activity pack. Get your grown-ups to have a look at it, or an older learner if they're helping you. It's loads of wonderful, useful information there. And so if you find these lives useful, please share them. Please tell other people about the group, Making Maths Fun for Kids of All Ages. We do live every day, Saturday night and Sunday morning. So there's something different. And then starting very soon, might be next week, we're going to be doing a project for the whole week. So we'll be playing games of the weekend, and every morning we'll have a different activity or a variation of the activity. So you'll be doing one big project for the whole week. Because in the Northern Hemisphere, we've got summer holidays. Some people in Denmark, they're already on holiday. In Spain, they're already on holiday. In England, they'll be on holiday in a week. And so instead of doing, this will not be aimed at teachers so much, well, still not. We're bearing in mind that people won't want to be doing school. So we're doing projects. So this is, for home education, it's perfect as well. And what else? Tell people about the group. And if you are on YouTube, or you know someone's on YouTube and they're not on Facebook, then we've got the YouTube page, groups, YouTube channels. So if you can subscribe to those, if you're on YouTube, that's Maths Toys, relates to specific activities, these aiming high activities. And there's Bubbly Maths, where we upload all these lives. Or sometimes I do a separate live because these lives haven't worked very well. Not that would ever happen to me. And also there are other activities on there, soap bubbles, balloons, making maths fun. That's what Bubbly Maths is all about. And we're starting to talk as well, starting to upload lives about maths anxiety to help families with maths anxiety. If there's anybody in the family that has it, it can be quite upsetting and disrupt the whole family. So we're all about making maths fun, making it a pleasant experience. All these activities we're doing are all aimed, are all suitable for someone with maths anxiety, because there's no pressure, there's no right, there's no wrong. It's playing games, it's being active, rather than being put on the spot to answer questions. And let me now see, thank you for joining, let me now see who came, oh my goodness, I didn't have too many open things here, who came to see us, who joined in. Oh, Zaz, well, I hope that Ollie and Zach joined in, I hope. And CJ, hello CJ, nice to see you there. I think I might owe you an email I've forgotten about. And let me see, you just reminded me. And oh, in Australia on holiday, when do you, oh, teach statistics before calculus. Thank you very much, Shane. Yes, we're doing that, we're on that. And we'll have a look at that. So there's a link that Shane has put on in the group. So that might be a useful thing for grown-ups and older learners to look at. I think it's going to be a very interesting look. A video on the importance of statistics. There you go. Thank you very much, Shane. Okay, I'm not quite sure what he's answering there, but what we are, so they're on holiday in Australia as well, so this is perfect. We're doing project-based activities. If I'm bored, you hear I'm bored, then come and do one of our activities, because you won't be bored if you're doing our activities. Find one. If you don't like one, find another one. You'll find one that you like. And that's it. I think we've had a look at everything. And that for the first time ever, I've managed to actually see the comments. I think I might be getting the hang of it finally. So thank you for joining us. In 21 minutes, we'll be doing the live for early years. And we'll see you then. And then of course it's all available on replay. Let's stop the live stream. Here we go. Thank you very much and see you next time.